You have heard of operational forecasts, operationalizing forecasts, climate forecasts. Here, this is an essay on the need to operationalize climate modeling. What do we mean by that? Let's see. Climate models have evolved from research tools to underpin decision making across the globe. To provide optimal value for society in the future, the models need to be made operational. Is this something new? What are the points that they are trying to make in this context? Climate models have changed the world, starting out as simple globally average representations of vertical energy exchange in the atmosphere in the 1950s. Today's climate models are highly complex numerical representations of the Earth system based on the fundamental laws of physics. Their development has largely been driven by scientific curiosity, with the many approximate virtual representations of Earth available today, enabling the interrogation of the past and present climate system, and the development of an understanding of the influence of human activity on its future, which is one of the main goals now, to understand where we are headed. It's this understanding that underpins the climate mitigation targets enshrined in the Paris Agreement to limit global mean temperature increases. I'm going to just take bits and pieces. Jumping ahead, several large coordinated modeling programs have strongly shaped the evolution of climate modeling. Since the 1990s, the Coupled Model Intercomparison Project, or CMIP, of the World Climate Research Program has coordinated global model simulations. CMIP is a climate research activity with its stated goal to better understand past, present, and future climate change arising from natural, unforced variability or in response to changes in radiative forcings in a multi-model context. Pursuing this goal, CMIP has made tremendous contributions to our understanding of the present and future climate system. Multiple petabytes of CMIP data are freely and publicly available and are used worldwide, mostly to crank out lots of papers about what will happen in 2100 to the Indian Ocean, the heat waves, and so on and so forth. The coordinated regional downscaling experiment, the vision of which is to advance and coordinate the science and application of regional climate downscaling through global partnerships, uses regional models driven by the CMIP model results to provide more localized information. So basically they take global models, CMIP 6 or CMIP outputs, and they downscale them to particular regions like the monsoon region, the Mediterranean region, US, and so on. And there are many papers showing whether they actually add value to the global simulations or make things worse, and so on. The IPCC regularly uses the results of CMIP and CORDEX to assess the state of the science of climate change and its impacts, and that's what is discussed here. Climate models and the IPCC. There is lots of controversies on this business, but let's not get into that. A key driver for the development of climate models in the past 3 decades has been the assessment reports of the IPCC, conducted with high regularity. Every 7 years now they are supposed to release. COVID delayed things a little. The reports impose rigid timelines on the modeling community in terms of following the protocol, producing the output, sharing them so that they could be analyzed before the report comes out. Coordinated by the CMIP modeling groups, produce a large volume of community agreed simulations that take several years to produce. In 1990, when the first IPCC report was published, it used 3 coupled climate models in its assessment. This increased to 17 in the second assessment report, increasing to 31 in the third assessment report, and 23 in the fourth assessment report. Jumped to 54 in the fifth assessment report. By the time the sixth assessment report came out in 2021-22, 61 global coupled climate models were contributing their simulations. In addition, 47 regional models were used to enhance spatial detail of climate model information. in regions of interest, because now IPCC is also providing regional scale information for the future projections, while it might, or even past analysis. While it might seem advantageous that there are now many more climate models, these models share components, and as a result they are not all independent, so a lot of incestuous modeling goes on. Furthermore, the growth in the number of climate models has not substantially reduced uncertainty in key climate indicators such as the equilibrium climate sensitivity, which basically means if you increase CO2 and double it, what amount of warming do you expect? That's called a climate sensitivity. Perhaps most importantly, an increasing number of research scientists around the world perform quasi-operational tasks, significantly reducing their ability to deliver model improvements. So you want to each assessment report has to have improved models, and resolutions are increased over time. For example, a lot of papers come out saying this version of CMIP suite of models is very similar to the last one, or that the improvements are very minor. So these are issues to deal with, just considering the amount of energy they use and the way they tie up personnel for years. So the status quo is that despite its undoubted value to society, climate modeling has largely remained a research endeavor. So large labs with resources can only run it. Researchers select areas of focus to improve the models, carry out the large volume of simulations for CMIP and Cordex, and assist in the interpretation of the results for decision makers. This has several notable negative side effects. First, the funding for model development depends on the commonly short-term and uncertain research funding process of individual nations, making long-term planning difficult. More than once during the decades of CMIP, its basic data infrastructure has been under threat as individual national research programs cut funding for it. Second, research scientists frequently pause their research for years at a time to deliver simulations for the CMIP IPCC process and help interpret them, halting critical model improvement. Thirdly, the decisions on model development are primarily driven by scientific curiosity rather than societal needs. Therefore, we argue that current climate modeling practices are not well suited to meet the new demands made by the society. We propose a solution to this: make climate modeling a fully operational activity instead of extended arm of research. Let's leave this here. This is how 7. Okay, let me go a little bit more. Here we are looking at the status quo again in a bit more detail. Current climate model development is carried out the current climate model development is carried out at an ever-increasing number of research centers across the world with the goal to improve our understanding of the climate system. Researchers decide what new processes to capture and what new questions to ask, largely based on scientific curiosity. The CMIP and Cordex international projects then organize a common set of simulations. Protocols have to be followed very strictly, so intercomparison is real and robust. And this collectively forms ensembles of opportunity that are used in IPCC assessments. In this process, researchers advance climate science individually with their models or collectively via the analysis of the CMIP and Cordex ensembles. The outputs are used by community members to produce a lot of papers and analysis. This has been very successful. CMIP and Cordex have transformed our scientific understanding of the climate system. However, the use of CMIP and Cordex in decision making frequently remains ad hoc, with limited regard for the fact that the models have been optimized for research. CMIP and Cordex provide an ensemble of opportunity rather than a custom designed system for societal applications. This means that issues identified in the use of the models in the policy, risk and solutions areas usually do not directly influence decisions for further model development, which remain driven by climate science. As a result, long-standing model errors in the simulation of key societally relevant climate parameters such as rainfall have remained unaddressed across several CMIP generations. Well, there are other details here. The information produced is reliable, let's say more for temperature, and that too at a regional scale. Let's say at the Indian subcontinent scale, they don't have skill at regional and local scales, and rainfall is quite bad at any scale. Models don't agree with each other, and so on. So there is lots of details as to why these are not used in decisions and policies and so on. Models are great because given the energy from the top of the atmosphere, given the energy at the top of the atmosphere from the sun, they can do almost everything, but there are always little issues. It's like a car that drives but always pulls to one side, so you want to take it to a mechanic and get it repaired, and that's what model improvements mean. Can that be done unless we can have time to stop at the mechanic and have it looked at properly? That's the idea of this operationalizing for ensuring constant stream of funding and personnel. So here we are in terms of status quo climate model, producing CMIP and Cordex, ensemble of opportunity for societal applications in terms of policy, risk and solutions. But you also want climate research and understanding to go on so that you can constantly keep improving the models and come back and loop this so that this is constantly getting better in terms of ensemble of opportunity for societal applications, and the argument is that's not happening. Let's read one more paragraph before we split this into another podcast. Operational modeling has been common practice for more than 40 years in numerical weather prediction, which underpins our daily weather forecasts. Weather forecasts help us plan our lives, make day-to-day decisions of increasing economic value, and save property and lives. Weather forecasts heavily rely on computer models that are close relatives of climate models. However, unlike climate projections, the model simulations underpinning the weather forecasts are made by operational modeling systems that are an integral part of the weather service provision to society. So the climate modeling for IPCC is a different set of labs and personnel versus operational weather and climate forecasts. There is operational climate forecast which does few seasons to a few years sometimes. Still they are run separately from the CMIP modeling that we are trying to operationalize here. So however, unlike climate projections, the model simulations underpinning weather forecasts are made by operational modeling systems that are an integral part of the weather service provision to society, well funded to focus just on that, to keep improving those models, their methods, data simulation, etc. And they have lots of observations dedicated to improving weather forecasts because weather forecasts are highly valued. Models are developed in institutions where the primary focus is to provide the best possible data for societal decision making, supported by research that continuously improves the systems. Using this operational approach has led to a steady improvement in the methods and results of NWP for the benefit of governments, businesses, emergency services, and the public. So it has direct applications in terms of managing weather events, disasters, decisions for flights, for buildings, transportation, energy, agriculture, floods, droughts, wildfires, and so on and so forth. So let's come back and do another podcast, since this is already 13 and a half minutes, but you get the point. So we'll make a few additional points for the need to operationalize climate modeling as in the CMIP class global models used for climate projections out to 2100 and beyond.